Assalamu alaikum everyone. So I'm back with another video, and today we are going to finish off organic chemistry and with the last chapter whose name is macromolecules. Macromolecules. Many students dread this chapter as well because uh, there are many intimidating structures. But again, like I often say, that you just need to get your basics right, and that's all. Macromolecules are also known as polymers in this case. Okay, so I have already discussed polymerization in short while I was teaching alkenes. In alkene video, there was a small introduction of polymers. Okay, the first thing that you need to know what is polymerization. Polymerization is when a large number of small units called monomers, when large number of small units called monomers join together to form a large unit called polymer, called polymer. Okay, that process is called polymerization. If there are n number of monomers joining together to form a large polymer, if m is the monomer, okay, if you're joining n number of monomers, then these monomers are going to repeat n times in a polymer. If you are joining n number of monomers, they are going to repeat n times in a polymer. Okay, primarily there are two types of polymerization. One is addition polymerization, and the other one is condensation polymerization. There is addition polymerization, and then there is condensation polymerization. Condensation polymerization. Okay, let's talk about addition polymerization first. We talked about this in alkenes. Let's say addition polymerization is when same monomers join together. That is a funny looking join, but I hope you get the gist of it. Same monomers join together to form a single product, that is polymer, to form a polymer. Remember, in addition reactions or in addition polymerization, there is only one product, there is only a single product formed. Let's take the example of polybutene. Let's say I have to make polybutene from butene. I have to make polybutene from butene. You have to take a lot of butene molecules and have to join them together, and you'll have polybutene. Now, butene molecules is normally written as this. I can write it like this: CH2 double bond CH. Okay, then CH2, then CH3. Okay, at 4 carbon atoms. This is the condensed formula. That's how you write a condensed formula. It is pretty much like the structure. You write the structural formula, na? You just you press it from above and below, and you'll get the structure. It's just that you don't have to write single bonds here. You just need to write double bonds here. So this is the formula of butene. Now, when you're going to open this structure, obviously this bond is going to open up. This bond here is going to open up. Now, this carbon needs space on the right, and this carbon needs space on the left. So whatever is attached on the carbon atom will go down. You can write it like this. You can now write this structure like this: C double bond C H, and then CH2 CH3. Okay, because you need space. This bond is going to be broken, and on the right hand side, on the left hand side, many monomers like these are going to join together. Okay, so how will a polybutene form? Let's write it down here. So polybutene, you have to break this double bond. Let's say I only have to write one repeating unit. Okay, I have to add a bracket. Okay, the first thing that you need to do is to attach all the branches H, and even this alkyl group. This is ethyl group, CH2 CH3. Okay, these are called the extension bonds. They tell you that on the right and on the left the chain is continued. This is what? This is polybutene with one repeating unit. Okay, this is the repeating unit. If they give you a polymer and they ask you to write a repeating unit, you are going to write a repeating unit like this. Okay, not without bracket. If I ask you to write the repeating unit of polybutene, you will simply write like this: C, C, H. These are the extension bonds. H. It's important to write extension bonds. Okay, CH2, CH3. That would be the repeating unit of this polymer. If they ask you to write the monomer of this polymer, what you have to do is you have to bring these extension bonds back. You have to bring these extension bonds back, and then you'll have to make a double bond here, because monomers have bond that is intact. Okay, in repeating unit you'll have to show the extension bonds. If in the monomer you'll have to remove the extension bonds, and instead you'll have to build a double bond between two carbon atoms that was initially broken, because in monomers carbon double bond is still intact. Okay, now the other type of polymerization is condensation polymerization. In condensation polymerization, different type of monomers react. Different monomers join together. Different monomers join together. Okay, and more than one product is formed. Other than the polymer, there is another product that is formed. More than one product. Okay, and that product is usually water. Water is released. Okay, let's discuss that. The first example of condensation polymerization is the preparation of nylon. Or it's also known as polyamide. Okay, let's discuss that. How is that formed? It is formed when dicarboxylic acid. What does it mean by dicarboxylic acid? It means two functional groups of carboxylic acids are attached on a single molecule. Dicarboxylic acids react with diamine. Amine is this group, NH2. Dicarboxylic acid reacts with diamine to form polyamide or nylon and water. How does this work out? Before writing this reaction, I need to tell you one thing. That let's say I don't even know how many carbon atoms are attached in a single carbon chain. Okay, it will get really tedious if we have to write all the carbon atoms. But instead of that, what do we do? We actually represent it with a box. We can represent it with a box. Let's say if all these carbon atoms have two OH groups, we can represent it with a box when we know that nothing is going to happen in these carbon chains, in these carbon atoms. Nothing is going to happen during a reaction in these carbon atoms. So we can represent them with a box. Okay, and we can write it like this. Okay, that should be I'm going to write over here. Now n number of dicarboxylic acid and n number of diamine are going to react to form a polymer. Dicarboxylic acid, how would you write that? So dicarboxylic acid would be box C double bond OH, C double bond OOH, n number of dicarboxylic acid. They are reacting with diamine, box, and amine is NH2, NH2. Okay, I'm just marking this box differently so that you know that this box represents the box of the carbon chains of the diamine group. How would polyamide be formed? Now, listen carefully. The OH of carboxylic acid and the H of amine, they react to form water. The OH of carboxylic acid and the H of diamine react to form water. Okay, if there is one of this and one of this, there's going to be two water molecules that will be formed. If there is one of this molecule and one of this molecule, two water molecules will be formed. But since we are taking n number of this molecule and n number of this molecule, then 2NH2O will be formed along with a polyamide structure. Now let's write that structure. Okay, now just follow me very carefully. This OH is gone, in this OH is removed in making water. Okay, so you are left with this C double bond O box C double bond O. Again, this OH is removed with when it reacts with hydrogen and formed water. Now this bond directly connects to this bond. This bond directly connects to this bond, and you can write it like NH box NH, and the other hydrogen is removed here. Okay, now this is one repeating unit of, if they ask you to write the one repeating unit of this polymer, you write two extension bonds here, one on the left, one on the right, but it is convention to write it two times. Okay, just write it a couple of times. So this is one time. Now repeat the structure from the start. C double bond O box C double bond O N H box NH box NH. Okay, there you go. There you go. On the left and the right, the structure is continued. This linkage, this CONH, this linkage is called amide linkage. This is called amide linkage. Since it is repeating again and again, that's why the structure is known as polyamide. That's why it is known as polyamide. Okay, and it's also known as nylon, commonly known as nylon. Okay, we know that nylon is used in clothes and stuff like that. You're already familiar with it. Okay, now let's move on to another example of the condensation polymerization. That is the formation of polyester. We are going to discuss the formation of polyester. It is an ester. Okay, so obviously it is going to take alcohol and carboxylic acid, but in this case we'll have dicarboxylic acid and dialcohol. So dicarboxylic acid and dialcohol will react to form polyester. Instead of ester, we are forming polyester and water. This is actually an esterification reaction, but taken to another level. But this is actually polymerization because we are taking n number of these and n number of these. Now let's get to it. Dicarboxylic acid, C double bond O OH, C double bond O OH reacts with dialcohol, n number of dicarboxylic acid reacts with n number of dialcohol, marking this box like this. Did I mark there? Yes, I did. So that's what the marking is. We know that with the marking, we know that this is the carbon chain of amine. Okay, again I am marking for alcohol so that we know that this is the carbon chains of alcohol, OH. Remember the OH, carbon is attached to O. Do not write it like this. You cannot write like this, OH. No, you cannot. You'll have to write it like this. O is attached to carbon. Okay, not H. Okay, so what will happen? Again, OH of carboxylic acid will attack the H of alcohol, and OH of the acid will attack the H of alcohol, and we'll have 2NH2O that will be formed, and you can write the structure as following. Okay, so OH is removed, you are left with C double bond O box C double bond OH is removed, so it attaches directly to this bond, attaches directly to this O. So box O, then you'll have to repeat the structure. C double bond O box, at least write two repeating units. C double bond O box O, and on the left and right the structure is continued because it is a polyester. This is a polyester. Its other name is pterylene. Remember, pterylene. This linkage over here, C double O linkage, the C double O linkage, this C double O linkage. This is called the ester linkage. This is called ester linkage. We already have seen when we, for example, wrote an ester CH3 C2H5. This is an ester. This C double O is this functional group. That is why the C double O is the same as this C double O. This is called the ester linkage. That's why it is called polyester, because ester linkages are repeating again and again. So far, the polymers that we have studied are synthetic polymers. They were being prepared in lab. There are also natural polymers. There are also some polymers which are natural polymers. Those who study bio, they already have guessed which polymers I'm talking about. The first one is called protein. Okay. Proteins are made up of amino acids. Okay, amino acids are joined together to form a protein chain. What is an amino acid? Amino acid, obviously, as the name suggests, has an amine group and a acid group. So there will be a carboxylic acid group and there will be an amine group in H2. It reacts with another carboxylic acid, okay, NH2, and carboxylic acid. These two amino acids are going to react together to form a protein chain. So OH from this and H from this will join together, and the structure we'll have is NH2 box C double O NH box C double OH. This looks like an amide linkage. And it is an amide linkage, but here we name it differently. We call it a peptide linkage. So they often ask you that proteins are like which synthetic polymers. You will say nylon because they have amide linkages, but their reactants are different, but their monomers are different. So remember that. Okay. Now let's move on to another natural polymer, that are fats. Okay. Now fats are pretty much like pterylene and they will have an ester linkage. So how would that form? They would be formed with carboxylic acids. I will take 3 molecules of carboxylic acid. Taking 3 molecules of carboxylic acids. Okay, 3 identical molecules of carboxylic acid. Reacting them with a molecule of alcohol with 3 OH groups. OH. I'm writing it in a form so that it will make sense once I write it, okay? That OH from here will attach with H from here. OH from here will attach with H from here. OH will attach with H from here. So you will have what? You will have C double bond O, CH2, CH, O, C double bond O, box, and CH2, O, C double bond O, box. This is what fat structure looks like. Okay, there is an ester linkage here. So they often ask you that which of the natural polymers are like synthetic polymers. Okay, and you'll tell them that fats are like pterylene or polyester. Okay. Now let's move on to carbohydrates. Carbohydrates are simple as well. Carbohydrates. Okay, don't get intimidated by these structures, by the way. Once you get them through by your hand, they're going to get easy. Okay, so carbohydrates. So glucose, I can write glucose like this. It may seem like a diol, it's a glucose by the way. And that glucose, OH, OH, okay, it will react together to form a chain that looks like this. O, O, box, O, box, and N. Other than that, there will be water that will be formed, n number of water molecules. Once OH reacts with OH, this O comes from there. This OH will react with the H of another one, and there will be an O connection like this one, and it goes on like this. Okay, these are glucose molecules. They are glucose molecules, and they are forming starch, complex sugars. They are forming starch here. Again, you need to know their formula, that is C6H10O5, C6H10O5N. Okay, so these are carbohydrates. One thing that I tell you so far is that in esterification, I told you, if you think about it, esterification is also kind of condensation reaction because water is being removed. So, one thing that I didn't tell you is that you can actually reverse this reaction. If you reverse this reaction, this would be hydrolysis. If you reverse this reaction, this would be hydrolysis. If you break down nylon, it will, with the help of water, in the presence of concentrated H2SO4 and heat, it will break down into dicarboxylic acid and diamine. Similarly, if you break down using water, if you break down polyester by hydrolysis, you will get what? You will get dicarboxylic acid and dialcohol. And similarly, with these natural polymers, if you reverse this reaction, if you hydrolyze it, which means that you're using water to break down a compound. If you hydrolyze amino acid, it will break down. If you hydrolyze a protein chain, it will break down into amino acids. If you hydrolyze fats, they are going to break down into carboxylic and alcohols. If you hydrolyze starch, you are going to get glucose or simple sugars. Okay, so that is basically the most part of the chapter is done. I just need to tell you a bit about plastics. Plastics which are made up of synthetic polymers. So there are some advantages and disadvantages that you must be familiar with. There are some advantages and then there are some disadvantages. What are the advantages? They are light, they are cheap, they are durable, they are long lasting or durable, same thing. They are lightweight, they're done, okay. That is easily shaped. What are the disadvantages? The durability is a disadvantage as well because they are biologically they are not capable of degradation. Okay, they're not capable of biological degradation. So we say that they are non-biological. That they are non-bio. Sorry, I'm just mixing up words. They are non-biodegradable. Non-biodegradable, which means that they are not going to be decomposed when exposed to environment for a long period of time. Most of the organic matter, we know that organic matter gets decomposed. That's how we actually got fossil fuels. Organic matter got decomposed when exposed to environment for a long time. Okay, but plastics do not do that. They are so durable that they are non-biodegradable, which means that they cannot decompose with time. As a result, the fact that they're non-biodegradable, that's why they cause pollution. And another is if you try to get rid of them by burning, they release toxic fumes. They release toxic fumes on heating. Okay. So let's talk about recycling of plastics. Recycling plastics also have certain advantages and disadvantages. They're just the theory part. You can even write some of them by common sense. So recycling plastics are going to save energy, obviously. It is going to reduce pollution. Most important is that you're going to reduce pollution. Okay. What are the disadvantages? Disadvantages that you're going to form bad quality products because you're using an already used product. So you will be forming a bad quality product. And to recycle plastics, you have to melt them. So like I explained before, when you melt them, toxic gases are released. Toxic fumes are released on melting. So that is the disadvantage of recycling plastics. Toxic fumes are released. Okay, so I think that's all from this chapter, and we're done with the theory and with the structural part of this chapter. Now we are going to quickly go through some past paper questions to wrap up organic chemistry. Okay, question number 1. Amino acids are essential building blocks in the human body. Macromolecules, whatever. Which macromolecules provide the body with amino acids? Proteins provide the body with amino acids. These four terms can be used to describe polymers: addition, condensation, polymer, polyester. Which two terms can be applied to polymer Z? Obviously, it is a condensation polymer. It looks like a nylon structure. Okay, and it is a polyamide. It's not a polyester. So 2 and 3. Okay. Moving on. In the addition polymer polypropene, what is the simplest ratio of carbon atoms to hydrogen atoms? So polypropene, let's write the structure of propene, C3H6. So the simplest ratio would be 1:2. 1:2. A carbohydrate such as starch can be represented as shown. We just did this structure here. So what was missing? Instead of X, there is basically oxygen. It is oxygen. X is oxygen. Okay, P is a polymer that has 6 carbon atoms in each of the monomers from which it's formed. Is not a polyester, and it was formed using condensation polymerization. What is the partial structure of P? So each monomer has 6 carbon atoms. This does not have 6 carbon atoms, so it is not the answer. This has 6 carbon atoms. This also does not have 6 carbon atoms. And this is not a. So they said that it was formed using condensation polymerization. This is formed by addition polymerization. So this can't be the answer. The answer would be B. Which of the following is not a condensation polymer? Polyethylene. It's an addition polymer. Fats, carbohydrates, proteins, they all contains which chemical elements? They all contain which chemical elements? Carbon and hydrogen, and there will be oxygen. Again, nitrogen is only present in proteins. So, which pairs of statements are correct? Fat contains this linkage. Yes, they contain polyester. Proteins contain this linkage. That is true. So 1 is true. Polyethylene is made by addition polymerization. True. Terylene is made by condensation polymerization. That is true. Starch can be hydrolyzed to produce sugars. That is true as well. Proteins can be hydrolyzed to produce amino acids. That is true as well. Terylene is a naturally occurring polymer. No, it's just synthetically occurring polymer. So the answer would be 1, 2 and 10. Which of these compounds would react together to form a polymer? So this is diamine, and we also have dicarboxylic acid. So 1 and 3, they both react together to form polyamide. So instead of box, they just wrote carbon chains. So don't get confused. In which of the molecules is the carbon double bond O group present in the linkage? Nylon में होता है, terylene में भी होता है. Both have yes. In nylon this is C double bond O NH. In terylene this is C double bond O O. So yes, it's A. Moving on. In the diagram, which two arrows correctly show the hydrolysis products of a carbohydrate and that of a protein? So carbohydrate, does it produce glucose? Yes, it does. Does it produce glycine? Glycine is what? Glycine is an amino acid. No. Amino acid produces, a protein produces glycine. So 1 and 4. Carbohydrate produces glucose and protein on hydrolysis produces glycine, which is an amino acid. So answer would be 1 and 4. So polyethylene is the addition polymer formed from monomer ethene. Which statement is correct? Polyethylene can be disposed of by burning. This produces carbon dioxide and water. Polyethylene decolorizes bromine water. No, it does not. It does not have a double bond. Polyethylene does not have a double bond. Its double bond is broken. Polyethylene has the empirical formula C2H4. No, its empirical formula would be CH2. Polyethylene is acted on bacteria so that it decomposes quickly when in a landfill site. No, it does not. They are non-biodegradable. The answer would be A. They can be disposed of by burning. How many of these monomers would react with the molecule below to form a polymer? This is dicarboxyl diamine will react with it. Dialcohol will react with it. Two will form. Two polymers can be formed. Which of the following is a type of naturally occurring polymer? Protein is a naturally occurring polymer. Don't confuse it with sugar. Sugar is also naturally occurring, but sugar is not a polymer. Okay. Starch is a polymer. Which statement about macromolecules is correct? We also have done this. Nylon and terylene are both polyesters. No. Protein and nylon have the same monomer units. No. Proteins have amino acids. Okay. Protein have the same amide linkages as nylon. That is true. Okay. Terylene and fats are esters but with different linkages. No, they have the same linkage. They have a ester linkage. So answer would be C. That's correct. Which two conversions are not examples of hydrolysis? Amino acids to proteins. It's not the example of hydrolysis. Okay, proteins to amino acids is the example of hydrolysis. Ethene to polyethylene is also not the example of hydrolysis. Proteins to amino acids is starch to glucose. So answer would be 1 and 2. So that's all from this lesson. I hope you enjoyed it and you got all of your ambiguities addressed. So until then, I'll see you with another video. That's all from Organic Chemistry. This is your teacher, Sir Atif, signing out. Allah Hafiz.